Few questions capture our curiosity as intensely as the story of our existence. Our civilization, species, and the tree of life. How do we come to be? Why are we the way we are? How do we evolve and change over time? Hello and welcome to Z. Please don't forget to subscribe and hit the bell icon. In a recurring dream, I find myself wandering through a cosmic library, running my hand over books that document the entire history of the universe. Eventually, I come across a book about us, tucked away in a forgotten, dusty corner. The first chapter details the birth of our solar system, the formation of Earth, the collision that created the Moon, the cooling of our planet, and the emergence of life. Skipping ahead through many chapters, I finally find humanity. If each chapter represented 100 million years, we wouldn't appear until chapter 45. From humble beginnings as microbes, our bipedal ancestors hunted big game, developed tools and language, and eventually invented agriculture. Civilizations rise and fall, creating science, literature, art, and war, leading up to us, now, here. This is what I had been searching for, just one more page to turn. But as I pull the paper across, the dream ends. Each dream feels so close, yet the answer always eludes me. It's frustrating because we are not at the end of the story. If humanity arrives in chapter 45, then there should be another 9 or 10 chapters ahead. Scientists estimate that Earth can support complex life for another billion years before the sun's growing luminosity triggers an ecological collapse, as discussed in one of our previous videos. Think about that, a billion years left on the clock. Compared to our human lives, it's an unimaginably vast stretch of time, an immense abyss of countless moments, a haunting expanse beyond ordinary understanding, a scale so vast that mountains will erode, stars will die, and galaxies will collide. Yet, time only moves forward, allowing us to learn fragments of the past but leaving the future a mystery. What happens to our civilization? How far do we go? How does the story end? We often think of human history in terms of centuries, antiquity in terms of millennia, and evolution in terms of millions of years. But a billion years dwarfs them all. Consider the Neolithic Revolution, the start of agriculture and animal domestication. Even if our civilization reset to that point, it was just 12,000 years ago. In a billion years, we could repeat the entire history of all civilizations 80,000 times over. Over a billion years, evolution comes into play. Microbes mutate rapidly over months, as seen with every flu season, but humans evolve much more slowly. The best data comes from the split between Neanderthals and modern humans. About 2.5% of European DNA comes from Neanderthals, indicating some interbreeding. This implies an evolutionary timescale of roughly 500,000 years, though anthropologists debate this number. Again, we're struck by the enormous scale. In the billion years ahead, there is ample time for humans to undergo dramatic evolutionary changes, potentially splitting into countless evolutionary siblings. These future descendants may be unrecognizable to us. Looking back a billion years, before the dinosaurs, the Cambrian explosion, animals, and even plants, we see a world dominated by single-cell bacteria and archaea. So, our future descendants could be unimaginably different. We can't predict what these future beings will be like because evolution depends on adaptation to the environment and competition. A technological species like us could interfere with this process, causing mass extinctions, selectively breeding new species, genetically tampering with life, or introducing artificial life. But will technological species persist? Perhaps humanity is a brief, unusual episode in Earth's history. Most of Earth's history lacks technological civilizations, so that may be the future's fate. Despite our failings and self-destructive tendencies, humanity has a track record of surviving and thriving through global transformations and across the planet. From pole to pole, desert to mountaintop, people adapt. Our intellect allows us to solve problems with tools rather than waiting for biological evolution. This has always been our greatest advantage, and it's hard to imagine a situation where that edge is lost. Civilizations may fall, but societal collapse is distinct from species extinction. We often think our intelligence makes us a gift to the planet, but perhaps we're more like stubborn infestations. We're not a gift. We're a persistent presence in the evolutionary tree. This raises the possibility of persistent intelligence. If humans speciate over millions of years, our descendants will likely be intelligent. If intelligence offers survival advantages, it may continue to thrive on Earth long after we're gone. These intelligent species may not be our direct descendants, but could come from whales, dolphins, crows, or ravens. They could fill the niche we leave behind. And intelligence might not be biological. We are developing artificial intelligence that could soon compete with ours. This is relevant to astronomers who wonder if we are alone. Intelligence differs from technology, and we know of many intelligent species. But we only know of one species, us, that developed technology. The Silurian hypothesis suggests a technological species could have existed 350 million years ago, yet almost no trace remains due to Earth's rapid weathering. Space infrastructure, however, would last, suggesting that if we don't see anything artificial on the moon, we might be the first spacefaring species. I wonder what a technological species 300 million years from now will think of the lunar descent stages left on the moon. What will their archaeologists infer from these remnants? I try to remain agnostic about the question of life and intelligence in the universe. Everything we know suggests we might be alone, but I would be thrilled to find evidence otherwise. I find it hard to doubt that a technological species might re-emerge on Earth, given today's starting point. But if many species emerge after Earth, it's a coincidence that we are the first. Astronomers often prefer the mediocrity principle, placing us somewhere in the middle. Assuming a future technological species emerges, our descendants would be essentially alien to us due to the vast time span. If we want to communicate with aliens, we can send a message into the future. Not through space, but time. We could leave a time capsule with information about us, perhaps even an AI to converse with future beings. This message might wait millions of years before discovery, a whisper from the past. The tragedy is we will never see that moment. Like grandparents who never meet their grandchildren, we must accept this distance. As we age, we feel the tragedy of not knowing what our favorite team will do, what technology humanity will develop, or what our family will achieve after we're gone. These mysteries go to the grave with us. Humanity may face the same fate, accepting the unknown. Our Earth is a tenacious oasis of life in a harsh cosmos. Its story may be one of many such worlds, or incredibly rare. Our role in this planet's history is profound, and at Chapter 45, we can't help but wonder what the remaining chapters hold. Will our species spread across the stars? Will AI mark the end of curiosity on Earth? Will we cycle through civilization rise and fall until Earth dies? Or are we the only technological life this planet will ever see? These questions fuel our imagination, aspirations, and choices for the future. The Earth's future is a topic that intrigues scientists and enthusiasts alike. Predicting what our planet will look like a billion years from now involves understanding complex interactions between geology, climate, biology, and astrophysics. This journey into Earth's distant future is speculative, yet based on scientific principles and current knowledge. Geological changes. Over the next billion years, the Earth's surface will undergo significant transformations. Plate tectonics will continue to shape the continents, potentially leading to the formation of a new supercontinent. Pangaea Proxima, Nova Pangaea, or Orica are some hypothesized names for this future landmass. Mountain ranges will rise and erode. Oceans will shift, and volcanic activity will persist, continually recycling the Earth's crust. Climate evolution. The climate will be heavily influenced by both internal and external factors. Solar luminosity is expected to increase by about 10% over the next billion years, leading to higher temperatures. This could result in the gradual loss of the Earth's oceans through evaporation, creating a more arid and hostile environment. Additionally, the Earth's axial tilt and orbit will experience changes, causing long-term climate cycles and potentially extreme weather patterns. Biological adaptations. Life on Earth will have to adapt to the changing conditions. As the planet heats up, species will evolve or face extinction. Extremophiles, organisms that thrive in extreme conditions, might become more prevalent. New forms of life could emerge, while others might disappear. The increasing ultraviolet radiation from a brighter sun will challenge life, possibly leading to the development of new protective mechanisms in organisms. Astrophysical influences. External influences from space will also play a role in Earth's future. The sun will continue its life cycle, eventually transitioning into a red giant phase in about 5 billion years. Before that, increased solar activity and cosmic events, such as asteroid impacts, could significantly impact the Earth's environment. The gradual drift of the Moon away from Earth will also affect tidal patterns and potentially the stability of the Earth's rotation. Human impact. If humanity continues to exist over the next billion years, our technological advancements could profoundly impact the planet. Geoengineering, space colonization, and other future technologies might mitigate or accelerate some of the natural processes. The Anthropocene, a term used to describe the current geological age, could leave a lasting legacy on the Earth's geological and biological records. Predicting Earth's future over the next billion years is a fascinating exercise that combines geology, climate science, biology, and astrophysics. While many uncertainties remain, the scientific principles guiding these predictions provide a glimpse into the profound changes our planet might experience. Whether through natural processes or human influence, the Earth of a billion years from now will be vastly different from the world we know today. Thank you for watching and see you next time.